If you are able to read comfortably, I'll proceed it. Okay, first one by in the first case, A is equal to. So look at the VSR value, 5 meter per second. So I think better you generate one generalized formula. You generate one generalized formula. What is the expression for? Anyway, we have to draw a diagram, no? Every case. Okay, there's a river bank. We'll have values. Theta is given with a start point. We will start at t equal to 0 as usual. This is a B. Now what are the values? We are. Anyway, first we'll go for the. What is the time taken to cross the river? Anybody formula? W by VSR cos theta. Is it okay straight away? This one. So we do have all the things, W, VSR and cos theta. VSR value is 5. VR, theta is 30. Let me keep values. So this will be W is 10 meter. I'll write down all the values.
Sir, W by VSR sin theta.
No, look at once I changed the diagram. No, you can't. That's why I told you. No, in physics, just like, sir, I know formula, I'll manage. No, based on situation you work out. Okay, theta. How is theta? Theta with respect to vertical, I took here. No, not getting.
Understood, sir.
Formulas, things will change. If you can't just stick on to then particular theta, what happened with respect to normal, I put it. So therefore, time taken is equal to W by VSR cos theta. W is 10, VSR is 5, theta is 30, cos 30. So this will be 10 by 5, so 3 by 2. So time taken will be 4 by root 3 seconds. What about the drift? How to calculate drift? This should be equal to VR minus VSR sin theta. Straight away, I'm writing you try to see that one. Like yesterday, what we discussed, that only we are applying it. So x equal to velocity of river. Velocity of river 10. VSR is 5. Sin 30, 1 by 2. So this, what is the time taken? 4 by root 3. So this will be 10 minus 5 by 2. So 4 by root 3. Okay, this will be x is equal to anybody value x equal to I will write it here. It will be easy for you to view also. What is the value of x? X is equal to 10 minus 5 by 2, 4 by root 3. Okay, what is the value? Anybody simplified one?
17.32, sir.
Plus you'll get, positive.
Yes, sir.
17.32 meters. Okay, now looking at the data, you tell me like where do you reach? Though it seems up the stream, so there's a river current, there's the width of the river. The river current will push him so that he will, this will be VR, and he will reach down the stream. This is the drift. So this is the end point. After what time is here? 4 by root 3 seconds. So try to see now, everything is available here. With respect
So they
to,
have given that root 3 is 0.6, no, sir. 1 by root 3.
okay, we'll substitute that value. Root 3 is 0.6, no? 1 by root 3. 0.6 into 4 will be 2.4 seconds. In terms of that. Okay, try to see this all. So now, what is the drift? Drift is positive. So what is this path with respect to ground? You ask this swimmer where he is heading. He said that I'm heading towards B. The river current will push and you will finally reach at point 50 meter. Check calculations once. Is it okay? So now, what is this VSR? Velocity of swimmer with respect to river. Shall I also call this as velocity of swimmer with respect to river in still water? Both are same. No? Velocity of swimmer with respect to river. VSR. What is the name for VSR? Will give velocity of swimmer with respect to river, flowing river, or with respect to still water. Both are same, sir. How come suddenly you are changing the sentence? So I'll this is something in books it's really troublesome. Velocity of swimmer with respect to river current or with respect to still water. Both are same. This is really will trouble you a lot. This particular thing, sir. How come still you are bringing? Is it possible for the river to be still? No, not there. No. So what do you mean still here? Actually, if the person, the boatman will it's a swimmer. No, let's take the boat. That one. The boat is moving in the river. Then if you check you ask the boatman if he's moving with a velocity VBR in a river. You ask the boatman. He feels the flowing river at rest. That's why this is brought here. It doesn't mean that it's the absolute velocity. Are you getting now? VSR, velocity of swimmer with respect to still water. Any reason for that? See, what is this is VS. Look at this one. What is VS? Velocity of swimmer with respect to ground it is. What is VSR? Velocity of swimmer with respect to river. And if you stand on the bank, how you feel? River flowing towards right. So this is one thing you have plenty of numericals instead of showing writing like this, no, with respect to river current, they're saying still water. So don't get confused here. Both are one of the same. I'll just give you the idea what is actually meaning of. Okay, you stand on the bank here. For what you say, river is flowing towards right. The person who is on the boat, the boatman, when the boatman is moving with a velocity VBR, you ask him what is the state of river. For him, the river appear at first. For him, the river will appear because he is moving with a velocity VBR. So you go back to VAB. A and B are moving. If A moves with a velocity VAB, then B will appear at first. This is the one simplest basic condition. You may not accept this. Sir, you are telling some story. You are telling some story. So I'll just take you to Okay, I'll give one. Already you know a little bit of relative velocity motion. So let's take like this. A is moving with a velocity. Already we discussed this concept. And B is moving with a velocity 3 meters per second. VAB, what you calculate? VAB equal to VA minus VB, pi I cap minus 3J cap. So 3I cap. I'm giving simplest example. At least with this, you should be able to catch it out. Okay, now you ask him. So there's a person is there on the ground. You ask him, what will be his comment? A is moving towards him and B is moving away from him. Is it okay? So what this person or this person, what he says? A and B are moving towards right with a velocity 5 meters and 3 meters per second. We'll ask A itself, a person standing on the A. When he looks at the ground, if he is with a velocity 5 meters. If I make A to move with a velocity 2I cap, or if I make him to move with a velocity
Sir,
VAB,
your voice is
Sir, your
cracking.
voice is
Sir, your
cracking.
voice is cracking.
I'll stop the video. Now, okay? Can you hear me? Okay, can you hear me? Anybody respond? Can you hear me clearly?
Yes, sir. Yes, sir. Yes, sir.
Okay, no, I'll continue. Yeah, fine. Okay, look at this. Now let A move with a velocity VAB. Though B is moving with respect to ground, how it will appear for him? B will appear at rest for A. Though B is moving for A, what happen? Person A, what happen? Will appear at rest. Because it's moving with a velocity VAB, no? Then B will appear at rest here. If they ask you drift, it should be like a not mod X, that one. Drift can be positive, negative, or zero, no? So based on that, what happen? You have to put a sign that one. If drift negative, okay, drift negative it will be. If it's positive, it will be positive. Not mod, need not to tell that one. Because drift can be positive or negative. Okay, no. If the A moves with a velocity VAB, then what happened to B? B will appear at rest. But what actually B is moving, no? Are you able to get the logic here? Though B is moving, if A moves with a velocity 2 meters per second, then B will appear at rest here. Sir, how it is possible? You can try now. After what time they'll meet, calculate that. Similarly, the A will take same time to meet B. Then after meeting B, what happen? The A will cross. Here also the same thing will happen. This is the best thing. So okay, both A and B are moving. If the A moves with a velocity VAB, though B is moving with respect to ground, but with respect to A, it will appear at rest. Shall I say that that still water, same idea here? The same idea of the still water. If you stand on the bank, the river is flowing. If the swimmer swims with velocity VSR, the river will appear at rest. So therefore, I can use word still water. Doesn't mean that the river is at rest. Got it idea now?
Yes, sir.
Yes, sir.
That's the one best. See, you have to analyze here. So nothing called like a formula. In physics, you don't get anything. You should always take an example. So I'll help you with further few more. A moves. Both A and B are moving. Now also what happened? No, what he says, like a B is at rest. Who is saying B is at rest? When the person A moves with a VAB, then B will be at rest. Not like 5 meters per second. I just changed the situation. Actually, he will be moving. The B will be moving, but for him, what's happened? He will still appear at rest. There's a thing, you know. But with respect to ground, they're moving. So therefore, since we are doing the frame A, no, so better you write it like this. This problem is with the in ground frame. The second diagram is in the frame of reference of A. We are showing this situation. In reference frame A. In ground frame. Okay, fine. Okay, now proceed in similar way. So I think already we got a formula, no? So what you are going to do here? Calculate T and X in every case and show what can be the possible values. Okay, work out, no? Just substitute VR and VSR sine theta. In this particular formula, substitute all this, then we'll check the diagram, how different cases the diagram will be. I'll come for second case. Can you hear me? Can you hear me? Anybody, please respond.
Sir, recording.
Yeah, I'll start it. Okay, let's come for that. Okay, now let's continue. I think the data, I'll write down the values. What all values need require that one. What is the data? W is how much? 10 meter. VR, velocity of the river. VSR for the second case will be 10 meter per second. VSR will be, okay, calculate the time taken. W by VSR cos theta. W is 10, VSR is 10, cos 30 root 3 by 2. So this will be 2 by root 3. 1 by root 3 is 0.6. 0.6 into 2 will be 1.2 seconds. Then what about the drift? Drift is given by VR minus VSR sine theta into T. VR value 10, VSR 10. This will be 1 by 2, 1.2. 5 into 1.2. 6 meter. So what is the drift now? So still it's positive only, you can see. This is VR, but it's less compared to previous case. So this will be VS. So you will reach somewhere at this particular position. Okay, I got X positive. What does it mean? Drift is positive here. Okay, no. So this is about the second case. You see, the drift got reduced, no, as I increase VSR. Let's take the third situation. In the third situation, just see once. I'll go for third situation. Third situation, VSR will be 20 meter per second. Okay, now in this case, we will start at t equals 0. This is a starting point. This will be VSR. There's a river current. Width of the river. Okay, now what is the value of VSR? In this case, it is 20 meter per second. The same thing. This is VR how much? Width of the river given 10 meter. Theta is 30 degrees. Value of VSR is here 20 meter per second. Okay, now check it now in this case. First, what is the method? First, you have to calculate the time now. W by VSR cos theta 10 by 20 root 3 by 2. 1 by root 3, 0.6 seconds. This is the thing. Then drift is equal to VR minus VSR sine theta into T. Value of VR is 10, VSR 20, sine 30, 1 by 2. Time 0.6. So I got the drift 0. What do you mean by that? The river current will push him in such a way that exactly will reach here. This is the end point. Okay, now how are you getting now? So here the drift is 0. You ask the swimmer where he is heading. He says that I'm heading somewhere here. But where do you reach? Exactly on the opposite point. Shall we call this the shortest path? I just picked up this. Is a very basic problem, so that in any other numerical you can manage comfortably with this idea. Last case, we'll go for it. VSR 30 meter per second. Okay, look at all the things. I'll scroll down. We'll go for last case, VSR. Okay, go for last case. We'll wind up the last case, this one. So is, let me take diagram like this. This is a start point. This is theta. This is the velocity of the same data. So from the formula, we'll get that information. Then we'll go for the path, indicating the path all. Okay, substitute everything now. So we'll start at point A, t equal to 0. Okay, as usual, t equal to W by VSR cos theta, 10 by 30 root 3 by 2. 2 by 3 root 3. Root 3 is 0.6, 1.2, so 0.4 seconds. Then what about the drift? Drift is given by x is equal to, this is theta, 30 degrees. So into time. Value of VR is 10 minus, this will be 30, 1 by 2, 0.4. So 5 into 5 for 20, minus 2 meter. What do you mean by minus 2 meter? The drift will be negative. So this will be the VS. You ask the swimmer, where is heading? D. And finally, you will reach C. This is the end point. Now, what do you mean by negative? Left side, no? And what is the time taken? Time taken will be 0.4 seconds. Getting the idea now? So tell me, like, which is the best rowing the boat up the stream or down the stream is the best option? Suppose you are a boatman. Which one you should prefer? You should prefer always the down up the stream. By varying VSR value. How to vary VSR value? The speed of the engine. I can control the speed of engine. Like how we have on bike accelerator, no? There also I can control the speed of the boat with respect to river. By adjusting that value, what I can choose the drift where I want, where the landing point on the opposite bank. See, landing points on the river bank is a very difficult. You can't land wherever the boat you want, only some specific points. So based on that, what happen? The passengers, where they want the landing. So based on that, you can adjust its VSR. This is what actually practically the things will happen like this. So rowing the boat up the stream is what you have. You will get advantage. You can control the drift by varying the VSR. There's a problem I took by adjusting the values of VSR. You can control also the theta. You can control also the theta. Here I took a theta to be fixed. VR fixed here. VSR is what varying. By varying VSR, yes, we can control the drift here. Okay, this is one very basic problem. What I given is a very basic problem, very good problem for students to really understand. Nothing, no need to read again a theory. Just all these ideas, no, the 4 cases will help you. Any conceptual question if they ask you? The drift what happen can be controlled by varying VSR. Yes, it is correct, no? The boatman can control the drift by varying its velocity of the boat with respect to river or velocity of boat with respect to still water. The answer is yes. Fine, okay. This one. So now we'll take the